This is Terra-Master D5 Thunderbolt 3 enclosure review part 2. This is ArtIsRight. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. My first review covers many of the foundations that I will discuss and expand upon in this second review. I'll leave a link up here and below so you can check that out. Based on many of the questions and comments, I've gathered those together and also done some more testing, including one with SSD. So I will be sharing with you a lot of graphs. Feel free to pause the video so you can analyze those graphs yourself. In addition to this, I have also found a software controller bug that's on the computer that you would install. When it communicates with the hardware controller in certain RAID type, it causes a driver failure, so I will share that with you so you can avoid the issue altogether. In addition to this, we'll also have a discussion about RAID in the world that we live in today and whether that is still important or not. And before we get into any of these, let me first start by saying, because these enclosures can be configured with redundancy, my recommendation is to still have a backup. That redundancy inside these systems are not a backup, because if more drive fails than what the RAID system can tolerate, then your array is considered crash, and depending on the RAID type, sometimes you may not be able to recover it. So it's always a great idea to have an on-site and preferably an off-site backup as well. Your off-site can be hard drive that you rotate every so often, or it can also be a cloud backup. There are different solutions out there, but just be certain that you have a backup. And an off-site backup is also important because if something catastrophic should happen to the primary location where this and the backup is stored, well, you know you can get the data from off-site somewhere. And what it really comes down to with all these backup is that you want to have that peace of mind at the end of the day, knowing that you can sleep happy and sound, that your data is safe. All right, a few bits I found out about the system, and one of the things I will commend Terra-Master on, even though this power supply is external to a unit, I mentioned in the first video, I want this to be a bit larger so we can use a computer power connector. Even though it's going to be heavier, I don't really care, but you know, they've done it this way, which is perfectly fine. But this used a barrel connection, and the one nice thing about their barrel cord is that they put in a little Terra-Master sticker there. You have no idea, for someone like me who have so many of these type of adapters, they all look the same. On the back of these, there is regulation, but normally these are generic parts that they pick up, and they don't have the branding of the same manufacturer as their enclosure. So being able to identify that this is a Terra-Master one, so when I plug this in, I'm not underpowering or overpowering it, is super awesome. So I want to point that out and commend them for that. Now, the next thing that I received in a comment is that the drive trays for these are plastic, and yes, they are. However, I have used many of the enclosures, including one that are priced about the same as these that are using plastic drive trays with quick release or quick mounting as well. I don't find them to be an issue. In fact, I like the fact that they use a plastic drive tray, because when you have, for example, a hard drive that is metal, you have a stamped stainless steel sheet, you screw those in, even though there may be rubber. When you slide these in, there's still metal guides on the inside. So the metal guides inside this enclosure, it's still, you know, built really well. When you have all those kind of metal contact, it creates a lot of vibration and a lot of noise. This also acts as a dampener as well. And you know, in my usage of these caddy long term from different enclosures, they haven't break or crack or anything like that at all. And if they do, these are standard accessories that these manufacturers sells all the time. So it's not really an issue. However, if you feel that this doesn't fit in your workflow, now you know that these use plastic drive caddies. All right, the handle. One of the questions I receive about this is, if I pull out all the drive, you know, all these 5 drives, pull them all out, can I, you know, access the handle? Can I pretty much screw it off? And the answer to that is you somewhat can, because when you pull out all these drives, you can have access to the first screw that mounts the front handle just fine. However, the back handle is hidden behind the metal railing on the inside of it that works as, you know, the thing that guides the drive in. So you have to pretty much take this entire enclosure apart in order to remove the handle. Now, that may interfere with the warranty in the system, so I don't recommend doing that. But if you do it, just know that you may carry those risks. Chances are it won't void a warranty. I don't know this, but I wouldn't recommend that you do that. Now let's talk about stacking. One of the comments I receive about this is the handle is put here to prevent stacking. This could be the case, but I really think that the model and the design for these type of DAS is very different than a NAS. A NAS is designed to sit there and serve file to multiple computers stationary. I think this is really more so designed so you can quickly grab it and take it to another workstation or hand it to the next stage in a workflow, or take this on location without having to worry so much about how do I grip this properly or how do I handle this well. So I think the handle is really more designed for convenience. It's just that it's a little bit obtrusive on the system, that's all. Another question that I have received is about noise and heat. So in my first test, I've done the testing with all hard drive, and the sound and the noise from it is predominantly, overpowered by the hard drive. So you have the hard drive spinning, you have the head seeking to get the data. That's where all the sound's really coming from. You don't really hear the fan as much. Now that I've done this second test with SSD, when I power this up, you can hear a low hum on the fan. It's not a high-pitched noise or anything at all. And if you don't sit this pretty much right next to you, if you sit this a little bit further away on your desk, under your desk, whatever that may be, I don't think you're going to notice the fan noise on these quite as much. And it still does keep the drive cool. So I recommend that you leave the fan in there and not get any ideas by taking the fan out. Now, the circuitry on this itself, which is on this side of the device, gets very slightly warm under long usage. It doesn't get hot or anything like that at all. It's just slightly warm. So, I mean, the heat itself is perfectly fine, and the noise hasn't been an issue. As far as heat goes with SSD, there's really not a lot of heat other than, the SSD producing heat. But, I mean, these are the 2.5-inch one. They don't produce too much heat. But if you're using hard drive, that's where the majority of the heat producer is going to come from in the system. So, another question that I also received is that, well, I can technically just plug these into my system, use them as a JBOD or as an individual drive without having to install the RAID driver, and that is not true. I have run this test already. So the way how this is designed is that the backplane for all the SATA connection on this device is run through the high point controller, which is the RAID controller on the system. So you do need to install the RAID driver before you can access the drive. Regardless of whether you configure this as a hardware RAID or not, you still need a driver. And now let's have a discussion about hardware versus software RAID and do a quick comparison between the pros and cons of each of these systems. So this is more so going to apply to a DAS, something like this. And when we take a look at speed, for instance, having a hardware RAID is going to write to the system that much faster, because if you think about it, there is a dedicated hardware RAID controller chip on these devices that is doing the data distribution, breaking down the data, deciding which data piece goes on what drive. When you use this on a software RAID, you're relying on your computer operating system to do the heavy lifting before the data gets sent out to the device. So this is causing some of the slowdown, and it's also using the resources on the system. When it comes to flexibility, having a hardware RAID is a little bit less flexible, meaning that you need to have the proper RAID controller, the driver, and all these other software installed in order for this to work. When it comes to software RAID, as long as you have an enclosure that can mount multiple drive and it's generally compatible with a system, for example, like a Mac, you can just plug it in. And if you take that to another Mac system, for instance, it will just work right away without needing to install any extra drivers or any software or anything like that. So those are some of the considerations regarding flexibility, whether you need more of that flexibility without installing a driver when you're using these enclosures. Now, when it comes to drive failure, having an enclosure like this, it can do an automatic rebuild. So the moment you put a new disk in, you power it on, it's automatically going to build the array up again. Granted, yes, there are going to be some performance penalty, but it's doing that on this array itself, so you continue to use your computer, you can continue to access your data without any issues. If you're using a software RAID, you're going to rely on the computer to do the data rebuilding and talking and communicating with the drive inside these enclosures. So that's going to cause somewhat of downtime. Again, it's also going to use a computing resource, and that computer needs to be on the entire time the array is rebuilding versus just having the array rebuilt itself on a hardware RAID. Lastly, it comes down to the controller and chip failure, and this brought up a really great point with one of the comments I received. And this individual does not want to use a hardware RAID because of the fact that the hardware chip or the hardware RAID can fail. And if the hardware RAID fail, well, you need to find a similar enclosure that has a similar hardware RAID chip in order for you to plug it in and get it to work again, which chances are is probably somewhat true. If they're in the same family, they may work, but this is one of those delineating things where it could work in some instances and it could not work in some others. So I could see why that is the case. But in general, in the world that we live in today, these manufacturing of these chips and everything have gotten so good that the chances for a hardware chip failure, it's not zero, but it's extremely low. And with performance gain and everything and having a backup on location, I would prefer to use a hardware RAID versus a software RAID based on the data and the testing result that I have been providing in the first part of this video and what I'm going to share with you in the second part as well. Now, when it comes to software RAID, that becomes less of an issue because you're relying on your computer to do the management and everything, so you're not really going to run into a chip failure on the computer, because if that chip fails, well, just move it to another computer. When I say chip fail on a computer, that means your computer is not pretty much booting up or anything at all, but you can just mount it onto another computer and work with it, so that's not going to be a problem. But these are some of the delineating features to be aware of. Now, the other thing that you can do with this enclosure as well, based on my testing, is that you can just mount the drive. And when you do in the beginning, if you have drive with data on there, you install the software on the Mac system appropriately and everything, they will just show up in this utility on the Mac as an individual drive. So you can use this as an expensive 5-bay hard drive enclosure, although I don't recommend that you do that because you're spending a lot of resources on this, and there are other cheaper options out there if you just want to use your drive that way. And with this in mind, I still discourage the use of JBOD, because even with this SSD, JBOD speed is not that good. You're taking all the risks without gaining any benefit for speed or redundancy on the system. So JBOD is still not a good idea, and I will share the result with you in just a little bit. And as I mentioned before, later on in this video, we will have a discussion about RAID redundancy in the world that we are in today as well. But now, one of the tests that I have done that I didn't share in the first video is a Thunderbolt pass-through speed. So on this device, on the back of it, there are 2 Thunderbolt ports and also 1 display port. But this Thunderbolt port can have the connection for the computer. The other one, you can link it to a display. It will send a signal to the display, but you can also link another USB 4, USB 3, or another Thunderbolt device to it. So what I am using to do this test is the Arico enclosure, and I've done an extensive review on this. I'll leave a link in the description below so you can check that out. But essentially, this is a USB enclosure, and I've connected this directly to the computer system and also connected this via the Terra-Master, and I've done a speed test on the two. Yes, there is a slight speed penalty, as you're seeing right now, but for the most part, I mean, it's not too bad, especially if you're running out of ports on the system. What it really comes down to with this is the drive I'm using on inside is a Samsung 970 EVO Plus 2 terabyte. It's not the fastest when it comes to write, but this is done in a control environment. So you can see that when we link to Terra-Master, there is a speed penalty on the write a little bit. When it comes to the read speed, the penalty is a little bit less, but yes, there is still that speed penalty when you're linking through an enclosure like this. For this test, I'm using 1 terabyte Samsung 950 Pro drive, and for file system, if I'm doing this on a Windows, NTFS would be the one that I would use. On the Mac, I would choose the file system based on the drive type you're using. So if you have spinning mechanical drive, HFS Plus is going to be more optimized for that. If you have SSD, then I would definitely recommend using APFS because it is more optimized. In the first part of my test, I have the mechanical hard drive, and I tested this with both HFS Plus and APFS. The transfer time between these two file system are pretty much identical. They are within the margin of error. So the best thing that you can do is choose the file system that's best optimized for the media type that you're using. Let's have a look at the capacity in the different RAID type. For this, I have a raw capacity of 5 terabyte. RAID 0, I would get the full 5 terabyte but no redundancy. With RAID 1, it will only do this with 2 disks only, so technically you could have 2 terabytes, but these 2 terabyte, as you're seeing right now, will be running as an individual 1 terabyte disk. They're not being mirrored to each other in any way at all between these two, so you just have those 2 individual disks. And with this setup, you also have one drive that is just left alone, not the most optimal setup for this at all. You do get redundancy, but it's not done in an intelligent way. With RAID 5, the easiest way to think of RAID 5 is that one drive can fail, so however many drive you have, assuming they're all the same capacity, minus one, and that's the capacity of the array you're going to get. So for this one, it's 4 terabyte, and I have full redundancy, meaning that if one drive fails, I can still plug it into the system, use this, access the data. If I plug it in a drive, it will rebuild. Yes, there is some performance penalty, but you can still access your data in real time, and it is safe. Then there's also the RAID 1.0, which will give you 2 terabyte. And the way how this works is that, as I said, this is set as a RAID 1 to mirror each other. This is set as a RAID 1 to mirror each other. And then both of these are then set that up as a RAID 0 with each other, so you gain some of the performance, but this is still not the most ideal way to set this up because you need an even amount number of disks, and one disk would still be left at the end. Then there's the last method that you can set this up, which is JBOD, to combine these all together to create a large storage pool. But JBOD comes with one big risk, and that is if one of a drive should fail in a JBOD system, your whole array is pretty much non-accessible because that drive is now gone. Because the way how the system sees it is that drive is part of the array. Based on my testing on this Terra-Master enclosure, that has been the case. And I've also tested this on the software RAID on the Mac as well. Pretty much you can't access the data on the array, so I don't recommend using this as a JBOD system at all. And for this, here are some of the drive speed in comparison using the controller RAID at 64K chunk size. So here is the single SSD speed, and when you compare this to the JBOD, they're pretty much identical to each other. But like I said before, JBOD, you're taking in all the risks that if you just want to run this as an individual drive, I would say just use it as a single SSD, and that's going to be the better way to approach this. If you want to get the most performance out of these enclosure, I recommend setting this up as a RAID 0, which is a risky thing to do, but you're going to get the most performance, and I definitely recommend having a backup with RAID 0. If you go with RAID 5, you still get a pretty good performance and also redundancy. So everything comes down to your workflow and weighing your own pros and cons and the system that you have set up for storage and backup in your workflow. Let's now have a look at SSD versus hard drive RAID along with single drive and JBOD speed. So first, let's take a look at the right. When we take a look at a single drive, SSD through this enclosure is faster than a hard drive. That's true. However, it's not anywhere close to the max where it should be, which is around 400 to 500 megabytes per second. So it is taking a performance penalty, which is why using single drive in these enclosures is not really the best idea. But you get this because there is a hardware RAID on the inside. So when we do, for instance, a RAID 0, it's pretty much head-to-head. This, however, does carry a lot of risk, so backup is important. RAID 5 with redundancy, the performance between SSD and hard drive is also head-to-head. The benefit that you get with the hard drive is for about the same price as an SSD, you get a larger storage on the inside, so you can create a larger storage pool. So that's something to consider with hard drive versus RAID. And the other thing too is that majority of the SSD drive that we can get on the market nowadays, that is the somewhat consumer or the pro consumer level, it's generally around 4 terabyte, and that can be really costly. For that price, you can get a much larger, for example, 14, 16, 18, or even just a newer 22 terabyte drive and use inside this array and get a very large storage pool. So those are some of the things to consider. When it comes to the read speed, they are pretty much head-to-head. Hard drive is running out, which is very interesting. RAID 5 is coming about just the same, and you can see that with SSD read is doing a lot better comparing to write on a single drive, but when it comes to RAID, they're pretty much really close to each other. And here's a chart comparing between both the read and the write for SSD and hard drive. So top one is going to be SSD write, hard drive write, SSD read, hard drive read. You can pause this to analyze the result and see the comparison. The highest bar in this chart that you're seeing right now is RAID 0. You're going to get the most performance. Next one down overall is going to be the RAID 5. And amazingly enough, this is something that you see in the other chart as well. The SSD read on RAID 1.0 is super high, but it's not necessarily the most optimal performance to set up this 5-bay enclosure. So for this test, similar to the first part, I have two folders. One of it is 78 gigabyte that has one big 4K movie file in there, along with a Final Cut Pro project. The other one is a large 60 gigabyte folder that contains Nikon DA50 45 megapixel RAW file along with a Lightroom catalog with all the previews and everything. And let's see how this transfer works. So this is RAID 0 using 64K chunk size. We're going to take a look at two metrics using a hardware versus software RAID on the system, and the file system we're using is APFS. So starting out at the chart at the very top, comparing hardware RAID versus software RAID, you can see that the timing or this performance is close to each other. However, the software RAID does win out by a little bit. But when it really comes down to file transfer time, for instance, with a 78 gigabyte video folder, you can see that the hardware RAID is performing much faster than the software RAID counterpart. And when it comes to the 60 gigabyte photo folder, amazingly enough, and I ran this test multiple times, the software RAID is able to handle these smaller files much better and much quicker than the hardware RAID can. So something interesting happening there. When we change this to 128K chunk size, comparing again hardware software, we can see that the read and write speeds really close to each other, although software RAID is just a touch faster. But when it comes to transfer time, having a video file, for instance, 78 gigabyte, the hardware RAID is still a little bit faster. And with the photo files, the 60 gigabyte photo folder, timing is really close to each other between those two. But more important is, and what I really want to know is how the file transfer speed is for the different chunk size, hardware and software. So starting with the 78 gigabyte video folder, you can see that hardware is generally doing better. But when we compare chunk size, just mind you as well that the top one is 64, 128 hardware, and then this is 64 and 128. So you can see that hardware overall is still winning in 128K chunk size when it comes to the video folder. And the hardware is still winning, although by a very small margin as well, on the 60 gigabyte photo folder. So those are just some of the metrics to think about and to consider when you're using this. Lastly, let's look at RAID 5. This is the hardware RAID 5 controller only because macOS can't do RAID 5. So with chunk size, right, they are about the same. With regards to read, the 128K is a little bit faster, but what's really more important is the file transfer speed. And if you take a look at this chart right now, they are pretty much identical. So with RAID 5, chunk size may not be as important as when you're configuring a RAID 0. Let's take a look at the SSD versus hard drive, hardware versus software RAID transfer speed. We're going to compare a lot of data, starting with the 64K chunk. For SSD, I'm using APFS. For hard drive, I'm using HFS Plus as the file system. And for this, we're going to see a comparison between hardware and software controller, SSD and hard drive. So SSD, hardware, software, hard drive, hardware, software. This is starting out with a 78 gigabyte video folder. And amazingly enough for this, the hard drive hardware RAID is still winning out and is winning out against the SSD. Amazingly enough, the software RAID is coming in pretty much third and fourth. So if you're working with a lot of videos, I don't recommend using software RAID because there is a lot of detriment in performance, especially on a 64K chunk size. So what about a photo folder? With that, we can see that the SSD software RAID, amazingly enough, is doing the best, and the SSD hardware and the hard drive hardware RAID, they're performing about the same. So these are things to think about if you're using 64K chunk size. When we bump the chunk size up to 128K, things start to change a little bit. Hardware is still doing really good, as you're seeing right there, and the hardware hard drive RAID is still doing a touch better than, for instance, the SSD software RAID. So for this, the video, their performance is about the same with each other, but I don't recommend going with hard drive and using a software RAID because, I mean, just look at the timing right there. You're close to, I would say, like tripling amount of time that you would take to transfer. When it comes to photo, they're pretty much identical to each other. SSD hardware RAID is going to be the fastest, but I mean, the hard drive hardware RAID is actually not that much further behind, so you can kind of gather the result from there. A few more things I want to point out. when you have a DAS system like this, there's no full-fledged operating system running on this enclosure. So what you're going to get is somewhat of a rudimental interface for RAID like you're seeing now. This is the RAID Manager Pro, which is the software that you would install on your computer system to manage your RAID system. And there is a bug in this software that I have found. This bug has to do when you set up your RAID as, for instance, a RAID 0 or a JBOD. These are the type of destructive RAID, meaning that there's no redundancy, and if one or more drive fail, it doesn't really matter. The whole entire array is considered crashed. So with this, you can see the array is functioning normal right now, and I have simulated a crash by pulling one drive out. You can see there's a little X on the RAID array, and the status is now disabled because you can no longer use this. Part of the drive in this array is now gone, and this is a destructive RAID. So what I have done is click on maintenance, to which this dialog will pop up. You can see from this dialog that a disk is offline right now. That is a drive that I have simulated the failure. However, in this dialog, there is the option to delete the RAID, to unplug, but there's an option to recover. And that's the one that causes a lot of havoc for me because I'm curious. So I clicked on that, and what I found is that when you click on recover in this RAID Manager Pro, it pretty much crashes the RAID driver that is installed on the system. So the page will go through a refresh and will say it cannot connect. You can try to launch RAID Manager Pro again, it won't go. The drive array that you have plugged in won't be recognized anymore. I mean, this utility won't even see it. And even though you pull out all the drive, plug it back in again so that it's like a fresh array, I mean, it still won't show up on the system. And it acts so much like a hardware failure that I have actually contacted Terra-Master to be like, hey, what's going on? Can I get a replacement unit? In our troubleshooting, they have recommended I reinstall a RAID driver, to which that solves the problem. So I have done the test again, click on recover, and still similarly, it crashes. I reinstall the driver and it works. So if you run into that problem, and if you're curious like me, just know, don't click on recover at all if you're running on any type of destructive RAID. This way you don't run into the problem that I have run into. And lastly, let's have this discussion. Is RAID still relevant in our connected world with cloud backup and everything? I would argue that if you are an individual or a small group of creators that produce a lot of content, having some type of RAID storage in your studio, it's going to be much more cost effective and gives you a better uptime than if you would have done the cloud solution solely. Or if you set up an array like this, but you don't want to use redundancy but rely on cloud backup, I still think you're running into a lot of risk, and that has to do with uptime. What it really comes down to is that you have to examine your workflow and what you need out of your storage solution, whether uptime is going to be important for you or not. Because if uptime is important, I recommend setting something that has redundancy in the inside, such as a RAID 5. Yes, even though one drive may fail in the system, it may take time to rebuild. There may be performance degradation during that time. However, you can still back up your data out of that array until the point that that drive fails. You can still back up the data up to that point, and you can continue to use the array with zero downtime. So if the data on your array crash and you rely on cloud backup only, which is not something that I recommend, you can certainly download the data backup from the cloud. However, that's going to take time. For instance, on my main storage system, I have 50 terabytes of data. That's literally going to take forever. And there's an analogy being made a while back that FedEx is still the company with the most bandwidth. So it would be much quicker for me to order the drive and have those drives shipped to me overnight, and I have to restore those drives to my system, than having me download using my internet service provider. Because even with the fastest internet service provider, you're requiring both ends and every single point in between to be at a high speed. Now, one of the things I want to point out in looking for these solutions is that Backblaze has their B2 solution, which is like a NAS backup for like huge storage and everything like that. And their price is not that bad. It's actually 0.005 cents. However, with 50 terabytes of data, for instance, let me kind of give you an analogy. I am looking at around $3,000 per year for storage, and that's still the cheapest option. Mind you, this is for uploading and storing it there only. If I want to download the file to restore in my system, well, I have to pay for the downloaded data as well. And this is not calculating that in. So for the amount of data you have and you archive, this is again individually based on the workflow. I still think that having RAID is a good idea, and also having the redundancy in the RAID system is something that is important today. So it's not quite as irrelevant as we like to think it is, even though cloud solution is paramount, especially when we're talking about, for instance, like 50 terabytes of data. I mean, if you're running on less data than that, under, for example, like a terabyte, going with any type of online cloud solution, Apple, Google, Dropbox, Microsoft OneDrive, for instance, would be a great solution. But anything more than that, you're really starting to look in at a lot of extra added costs. So anyway, what it really comes down to it, all of this and the backup solution is just, as I said before, a peace of mind. I hope that you find this second part of the review, which is a lot more in-depth, helpful. If you have any questions or comment, leave them below. Give this a like, subscribe, and hit on the bell if you're new. And in Art we trust.